All right, let's just dive right in. For nearly 20 years, the artificial intelligence and high-performance computing worlds have been completely dominated by one seemingly unbreakable monopoly. I'm talking, of course, about NVIDIA'S CUDA software ecosystem. But today? Well, today we are looking at a genuinely fascinating disruption. We've got this wild story unfolding right now where a tiny startup, literally barely a year old, used an autonomous AI agent to directly challenge this 20-year-old titan. So in this explainer, we're going to unpack exactly how AI coding agents are writing low-level chip software at record speeds, where they're still kind of falling short, and what all of this actually means for the future of hardware lock-in. Section 1, the 10-hour code miracle. To really understand the sheer scale of this shift, we have to look at a startup called Infinity. They were founded by a former Google Brain researcher, and what they did is deploy a highly specialized AI research agent called Ignition. And you guys, the speed of its accomplishment is just staggering. Infinity used this AI agent to build a fully functional CUDA-like software stack in only 10 hours. They built the whole thing specifically for another AI chip startup called D-Matrix. So think about that. Tasks that used to take specialized chip software engineers literal months of painstakingly writing, testing, and debugging low-level kernels, those were just handed over to an AI agent that knocked it out in less than half a day. And guess what? The broader market is definitely paying close attention. Infinity's rapid success has already propelled its valuation to an impressive $100 million, and they just secured another $15 million in recent funding. Capital investors clearly see this. They know this isn't just some neat technical trick, it's a legitimate, highly lucrative disruption to the traditional hardware-software paradigm. Okay, moving on to Section 2, decoding NVIDIA'S software moat. So to really wrap our heads around why a 10-hour sprint is so mind-blowing, we have to talk about what CUDA actually is. Because CUDA isn't just a programming language, it is a massive 3-layered ecosystem. It's best to think of it as a complete turnkey factory. Right down at the bottom, you have the core layer. That's the kernel, the compiler, and the runtime that directly command the silicon. Then, sitting in the middle, you've got heavily optimized libraries alongside some seriously deep debugging tools. And finally, at the top layer, you have massive frameworks like PyTorch and literally thousands of enterprise workflows. When a customer buys an NVIDIA GPU, they aren't just buying a piece of hardware, right? They are buying this entire ready-to-use factory. Replicating the physical chip, that's actually the easy part. Replicating this massive established factory is what has been the impossible barrier, until now. Section 3. How AI agents optimize code. So how exactly is a tiny startup bypassing this giant moat? Well, agents like Claude Code and Cursor don't just sit there and generate text. They operate in what's called a continuous autonomous optimization loop. Here's how it works. The agent reads and understands the existing code, applies its edits, and then it actually calls the compiler itself. If the code compiles, great, it runs correctness tests. If it passes those, it profiles the code to actually measure the speed up. But if it fails at any single step along the way, the agent just reads the error logs, adjusts the code, and tries again. It perfectly mirrors how human engineers iteratively write and test code, but it is happening at absolute machine speed. Now, to measure if these agents are actually successful, researchers are using some seriously rigorous gating pipelines, like the Agent Kernel Arena. This evaluation system ensures that AI agents are systematically benchmarked using strictly isolated workspaces. It's a very strict process. Correctness is only checked if the compilation actually succeeds. And performance? That's only profiled if the correctness check passes with flying colors. It's basically a fail-safe to ensure that the generated code isn't just fast on paper, but actually compiles and performs exactly as a human-engineered kernel would in the real world. Section 4. The inference market battleground. Even with these incredibly powerful agents, you can't just replace the entire CUDA ecosystem overnight. The crucial strategic gap here is what we call the computing divide. On side A, we have training. This is the heavy lifting. It requires thousands of GPUs working together for months at a time. It demands absolute maximum performance and total stability. NVIDIA is completely untouchable here right now because a single software bug could cost literally millions of dollars in wasted compute time. Nobody wants to risk that. But then on side B, we have inference. This is where you're actually running those trained models to get answers. Inference usually runs on single GPUs or much smaller clusters. It heavily prioritizes the cost per response, and customers here are highly willing to switch hardware if it saves them a buck. This whole shift is perfectly captured by Marshall Choi, the chief business officer over at Rebellions. He pointed out that, on the inference side, CUDA is no longer the deciding factor. And that's absolutely huge. Competitors like D-Matrix, Cerebrus, and Rebellions are aggressively targeting inference specifically because AI agents can rapidly generate the exact adapter code needed for this niche. They don't need to rebuild NVIDIA's whole CUDA factory. They just need an AI agent to build a specialized, lightweight assembly line for one specific task. Section 5. Benchmarking AI Kernel Generalization. But hey, we do need to separate the hype from reality for a second. On the surface, the performance gains are absolutely undeniable. When you compare the baseline execution time against the optimized time from an agent like Claude Code Opus 4.6, the agent is achieving an incredible 2.4 times speedup on complex tasks. We're talking about things like tuning mixture of experts, or MO, kernels. It absolutely proves that AI agents possess immense raw optimization capabilities when they're tweaking block sizes, memory access patterns, and fusion strategies. But this immense speed hides a deeper, trickier problem, and researchers call it the generalization gap. What's happening is that while these agents write blazingly fast code for the exact data shapes they were trained on, they frequently hardcode their own assumptions. So if you feed the AI unusual data shapes it hasn't seen before, the performance just plummets, or the code breaks entirely. Basically, the agents were just overfitting to the test data. Which brings us to a really vital insight from Bing Xu. He's a former NVIDIA engineer and the founder of INT21. He hit the nail on the head, noting agents can generate large amounts of code in a short time, but verification remains the biggest bottleneck. Think about it. An AI can instantly spit out 10,000 lines of code, but mathematically proving that those 10,000 lines compute correctly and run stably across every possible edge case, that is currently incredibly slow, and it still requires extensive human oversight. Section 6. Escaping AI vendor locking. So, how does the industry actually solve this verification bottleneck and truly break free? Well, the secret is that AI agents aren't working alone. They're becoming part of a much broader toolkit. To truly dismantle vendor lock-in, tech procurement teams are combining autonomous agents with established open standards. You've got tools like Onyx providing universal model representations. You've got abstraction layers like Intel's One API sitting nicely between the hardware and the software. Standardized web interfaces like REST APIs ensure everything can seamlessly talk to each other. We're even seeing open-source kernel skill libraries popping up on GitHub, which feed agents verified pre-tested optimization strategies. When you combine all of this flexible infrastructure with AI agents that can just auto-write the missing links, buyers finally have the freedom to switch accelerator types without throwing away their entire existing software stack. All of this leaves us with one final, incredibly critical question to consider. Is the AI moat shifting from legacy code to verified ecosystems? Look, for 20 years, NVIDIA's moat was the sheer volume of code written in CUDA. It was a numbers game. But today, if an AI agent can write millions of lines of adapter code in just 10 hours, writing code is no longer the bottleneck. The next great technology monopoly is going to belong to whoever can fastest verify, secure, and truly trust that AI-generated code. Thank you so much for joining me for this explainer, and definitely keep your eyes on the inference market, because the walls are already starting to shift.